Alright, so I'm going to explain dark matter very, very simply. Okay, so it's a sound frequency. Alright, so stars, they're very loud. E equals mc squared. Alright, that means that the energy that it's going to put out, okay, so the energy equals the mass of the sun, or a singularity or anything. It's a mass, its own size, times the speed of light squared. That's an explosion. That's the Big Bang, okay? The Big Bang is E equals mc squared. All right, I'm getting ahead of myself. Anyway, regardless, all of this nuclear energy, all these explosions on the sun are loud, but there's no atmosphere, so it can't perpetuate or traverse space, but it lingers, all right, because it's energy. It's very loud sound frequencies. Can't be seen nor heard because space. There's no air in it for propagation, but we can feel it, all right, because it gives momentum to galaxies. There's a bubble, all right, that gives a spin to galaxies. That's the dark matter. All right, so if you, okay, say you put your ear up to a cigarette, you can hear it sizzling and popping and crackling, all right, and then you see the smoke coming out. Okay, that's E equals mc squared. That's basically taking one form, turning it into another. All right. Campfires. If you're around a campfire, you notice the smoke always follows you. Smoke following beauty, the myth. Okay. It's not following beauty. What it's doing is whenever you're, say, in a radius around it. Okay. Smoke wants to go to the matter, distorting the area around the fire. Okay. That's the space. That's the two right here. That's the area, the radius, the area. All right. The speed of light squared. The speed of light in an area. All right. So, if you're by a campfire and the smoke keeps following you, it's because you're distorting the air around it. Okay? So you're distorting the air and it wants to flow straight to that matter. So you have to consider space is the same. Space is analogous to an atmosphere. The waters of space, it operates the exact same way our air atmosphere does, or a water atmosphere, because it's malleable. Okay, so all these stars are very loud, right? Well, the closest matter to a galaxy is the galaxy itself. Okay, galaxies are billions of light years away from each other. Okay, they're really far away. So any sound is going to want to go to the closest area, which would be the matter inside the galaxy. Okay, now, say you scream in a gym. Like I explained this on a video before. Say you scream in a gym. There's nothing in there. It's empty. The sound waves are going to traverse, they're going to bounce off the walls, they're going to come back, you're going to hear an echo, all right? And they're going to cancel out eventually, all right? Okay, now if you put couches in a building, in a loud gym, and you yell, the sound is going to get absorbed by all this matter, okay? So it's not going to be a big loud echo. You're not going to get a loud echo back. That's why whenever you move into a new home, you know, and you speak and you're just talking casually to somebody in a new home that's empty, it's all loud and echoes. But then when you move a couple couches and chairs in there, put your TV and your stand and all that stuff in there, you can talk casually and there's no more echo. Because all of that is getting absorbed by the sound, or the matter. See, light and sound is symbiotic. There is no light that does not have sound. There is no sound that did not originate from some type of light. Now, I am speaking, yes, but I am a star. I'm a singularity. I'm energy. I'm quantum, nuclear energy, and electric energy, just like any other human or any other life on this planet. Okay, we are the light. We're carbon-based. We are stardust. Okay, we are from the light. All right, we are biological, living stars. We are living, biological, animated stars. Okay, that is a fact, and it can be proven, but it's not told to us, which I think it should be. Because it's science, man. It's what makes us better. Okay, so when you have a magnetic field, see, it deters a lot of these particles. Now, if you put, say you can't hear anything in space, but if you set up a device that can basically turn everything into space into what is a sound, then it's loud. You'll hear it because space is loud. Okay, there's particles, charged particles moving everywhere. Okay, and that has sound. If there was no magnetic field to deter these particles, we would get waves of it. Now, we do get interference, and our atmosphere does get pushed and distorted a little bit because of these. But for the most part, that's why the wind blows. Or one reason the wind blows. But for the most part, it goes around the sun or the planet. See, if you were standing, if you say you were floating out here in space, the sound from this star would kill you. It would blow you apart. It would atomize you. The sound, just the sound of it. It's loud. It's so loud it would destroy every particle in your body. It would atomize you. So that's E equals mc squared. You're going to get an action and a reaction. Okay? If you have all this loud sound, then it's got to be there. Okay? It's not like this star's loud and all the sound just doesn't exist anymore whenever it happens. You know, that sound's still there. It lingers. It can't, it's like smoke. It can't propagate like a domino effect. All it can do is linger around. And it's going to go to the closest matter that it can possibly go to. And it's going to absorb into the matter. Alright, see, sound frequencies. It's all about sound frequencies. Waves. See? Imagine this is space. This paper's space. And this is the particles that are matter inside the space. Okay? The CMB and the ether are the sound and light that flashed when the Big Bang began. I mean, the proto-light. That still exists. That flash of light and the sound still exists. The CMB helps formations. And every galaxy has a unique sound signature because of its stars and the frequency of the stars. Okay? And that's why they all look different. See, this is the matter, and the sound frequencies will literally help that matter form into a galaxy or whatever, an accretion disk, whatever it's needing to form. The sound frequencies of the echo of the Big Bang and the stars around will help it form. There are two different, there's actually a couple of species of dark matter. The CMB is a species of dark matter.